Good morning. I'm Dr. Sanjay Jain, Associate Professor in Mathematics at SPC Government College, Ajmer. Today we extend our lecture in Continuum Mechanics. Earlier we have studied an idea of Cartesian tensor and vectors. Today we are studied some more laws for Cartesian tensors. We already seen some definitions. So we come to the transformation law of a vector. As we earlier seen that the vector A can be expressed in the index notation referred to any arbitrary set of right-handed Cartesian system, that is vector A equals to A E1 A1 E1 plus A2 E2 plus A3 A3. In the present system, we have taken two axis system. One is known as prime axis, second known as unprime axis. You are seeing here two types of line. One is dotted and other is dark line. The dotted line is prime right hand Cartesian axis and the dark line is unprime right hand Cartesian axis. So we have a two axis system. In that figure, the bold or dark bold line A shows the vector A from origin to A. P point to A point, there is an A vector, dark line. Okay. In space and will be referred as a set of unprime right-handed Cartesian axes with origin O and to set of prime right-handed Cartesian axes at O dash. Both set of axes may be translated without rotation to the common point or common origin at P without loss of generality. In the following discussion projecting A bar into unprime axis, given the Cartesian component AI and onto the prime axis AI dash. So what we want now, a point coordinate system when unrotated AI in the in one set of axes AI and in other set of axes they are AI dash. How it is now desirable to understand how the coprime component AI dash are related to the unprime component AI and vice versa. That is an important law. How we relate AI to AI dash from one Cartesian system to another Cartesian system. Here we introduce direction cosine between the two set of axes as follows. We are defining here A11, A12, A13. One is common in all that. So direction cosine of the y1 dash axis, one is common, that's why. Direction cosine of y1 dash axis with respect to the y1, y2, y3 axis. What we are seeing here, the prime axis of, or we say dash axis y1 dash with the other all three without dash axis, that is y1 y2 y3. Okay, that is known as a11 a12 a13. Okay, when y1 dash with y1 it is becomes a11. When y1 dash with y2 that is a12. When y1 dash with y3 this is a13. Okay, so these are three direction cosines of y1 dash with y1 y2 y3. Similarly, when we consider A21, A22 and A23. What is common? 2 is common. So here direction cosine of the y2 dash axis in as per earlier y1 dash, it is y2 dash. Now we consider y2 dash axis with respect to the all three unprime y1, y2, y3 axis. Okay, same meaning. Similarly, when we consider direction cosine of the y3 dash in place of y1 dash in place of y2 dash as earlier, now we consider y3 dash axis with respect to the y1, y2, y3 axis. So these are the three direction cosine with one axis to other axis in three dimension. Sometimes it is more convenient to summarize this set of direction cosine in tabular form, which is more easy to recall. Okay, so we are seeing in the next slide. Yeah, this is the table. Direction cosines between Cartesian axes. Okay, one sided we have taken the direction cosine of dash axis. Y you are seeing in the very first column y1 dash, y2 dash, y3 dash. These are the prime axis notation. In the first row you are seeing unprime y1, y2, y3, and y1 on y1 dash both are 1 1, so a11, y2 on y1, that is a12, y1 dash on y3, that is a13. So first row are a11, a12, a13, y1 dash is common. In second row or third row, y2 dash with y1 with y2 and with y3 are a21, a22 and a23. Similarly, in the last row, y3 dash with y1, y2 and y3 becomes a31, a32, a33. Okay. So prime axis and the second unprime axis, thus, for example, a31 is the direction cosine of the angle between y3 dash axis and the y1 axis. Okay, this is just for example. It is now easy to relate the two set of Cartesian component AI dash and AI. Recall from analytical geometry and vector analysis that the projection of the vector A bar onto the y1 axis or AI1 axis is equal to the sum of the projection of AI component on the same axis. Okay, using this law, what we can write, A1 dash is nothing but A11, the component of these, y1 dash is a1 dash component. Similarly, y1 component is a1. Say, as per in general way, we can say yi dash components is ai dash and yi components are ai. Okay, so when we can write a1 dash of component of y1 dash is nothing but just a11 into component of y1, that is a1, plus a12, first row multiply the component of their corresponding axis. So a11 multiply with a1 plus a12 multiply with a2 plus a13 multiply with a3. Similarly, y2 dash component is a2 dash. So a2 dash can be written second row element with their relative components. So a21 a1, a22 a2, a33 a3, sum of all these. Similarly, for third component a3 dash, we have taken a y3 dash row, that is third row. So a3 dash is nothing but component A31 multiply with component of Y1, that is A1. So A31 A1, A32 A2, and A33 A3, sum of all these. So transferring these three equations can be written in that form, row wise. AI dash is nothing but Aij Aj. You can easily see there are two indexes, so they become in some form for I and j. When I is fixing, A1 dash I become 1 and j become from 1 to 3. So we get all three equation. So this is the transformation law. Ai dash is nothing but Aij, small aij, and Aj. Okay. Now interchanging the role of primed and prime axis. Now if we want to change, we can take from unprimed to prime or prime to unprime. Vice versa, we want to know. So we can say A1 is nothing but column wise multiplication now in place of row wise. In earlier set of equations, we are taken row wise, now we take column wise. So what we get, A1 is A11 A1 dash, A22 A21 A2 dash plus A31 A3 dash. This is first column of Y1 multiply with components of yi dash. So when we written this one into in index notation form, this become ai is nothing but aji aj dash. Okay, this is law, transformation law, when we change from prime to unprime and unprime to prime. So these two equations having transformation law for the Cartesian component of a vector, they can thought as a definition of a vector set of three Cartesian components satisfying these transformation law, called a vector ordinary three-dimensional space. What you are seeing here, a one dimensional index I to j. Okay, how to change ai to aj, that is an important, that is in a tensor of order 1, and we already say in the earlier lecture that tensor of order 1 is nothing but vector. So these are the laws of the vector from one axis to another axis. Okay, so this is a vector law or Cartesian tensor law of order 1 from one axis to another axis. Okay. Now one more we have to see for as an example. This may ask in the examination many times. Yeah. What is this example? The component of a vector A bar in a set of unprimed Cartesian axes R. We are given a component AI. AI means A1, A2, A3. A1 is 1, A2 is 1, A3 is 0. Okay. Consider a set of prime Cartesian axes we have given to unprime Cartesian component, and we want to know set of prime Cartesian axis components. But the condition is consider a set of prime Cartesian axes obtained by rotating the unprime axis though an angle 30 degree about the y1 axis. About the y1 axis is an important task. Here you have to fix y1 axis. It may ask in exam, it may y2 axis also, it may y3 axis is also. So question may change in three way, that the unprime axis through an angle 30 degree about the y1 axis. Now the question is, what are the prime component ai dash of the vector? Ai is given to you, and after rotating 30 degree the Cartesian axis about the y1 axis, then what is the prime component ai dash of the vector? We already know or studied here just before that the relation between ai dash to ai. But the Cartesian set of axes rotated 30-degree about the y1 axis. Okay, so you are seeing here a diagram. In that, vector is showing by the dark line and their set of two Cartesian axes y1, y2, y3 and y1 dash, y2 dash, y3 dash. What is an important? That about the y1 axis, that is an important. See here, about the y1 axis is, so y1 is an fx, y1 and y dash are the same. You are seeing here that are parallel and laying on each other. Y1 and y dash are same. But y2 and y2 dash having an angle of 30-degree of rotation. Similarly, y3 and y3 dash is also having an angle of 30-degree rotation. Okay. So for the transformation law, we are seeing a table of A1 1, A12, A13, A21, A22, A23, and A31, A32, and A33. So we need to calculate these Aij. Okay, what is A11? Direction cosine of the y1 dash axis with respect to y1 axis. So A11 is nothing but cos 0 because y1 and y1 dash are the same line. So angle between them is 0. You are seeing this because in this book the direction cosines are written directly. But for example, we are solving here a11 is cos 0 is equals to 1. That is in a very simpler way because y1 and y1 dash. A11 is nothing but direction cosines between y1 and y1 dash. And both axes are same because the Cartesian coordinate system rotate with the y1 axis about the y1 axis. So y1 axis are same and y2 y3 rotated with 30-degree. This can also be understand by the next slide, and then we come to again here. Yeah, this one. What we are having, uh, three axes showing in red, blue and yellow. Okay, this is nothing but length, breadth and height of a room. You can easily understand by this way. And the dark green base is called the floor of the room. Okay, the y1 axis of red line is fixed, means height is fixed of the room, and plane room floor is rotated by 30-degree. So y1 is fixed and floor is rotated. So y2 dash and y3 dash rotated. That's why y2 dash and the angle between y2 and y1 is 90-degree. Similarly, y2 dash and y1 dash is also 90-degree because height is fixed, height is not changes, and the position of the plane or floor of the room it changes. So angle is always 90-degree with the floor. How that changes? No problem. Okay. So y2 and y2 dash having angle of 30-degree rotation, y3 and y3 dash having all an angle of 30-degree, but the angle with y1 or y1 dash with the y2 and y3 axis or y2 dash or y3 axis having the same angle 90-degree. Okay, remaining angle is calculated in this way. So you can now understand easily. First A11 is already one, we are seeing A12. What is A12? Direction cosine of y1 dash with respect to y2 axis. So the angle having 90 degree as we see earlier. So A12 is nothing but cos 90, that is 0. Similarly, A13, direction cosine of y1 dash axis with respect to y3. So this is again 90 degree because height is fixed. Okay, so A11, A12, A13 become 100. Now A21, A22 and A23. Direction cosine of y2 dash axis with respect to y1. But y1 and y1 dash are same as y1 dash perpendicular to y1 dash. So yi dash perpendicular to yi dash because they are both are same. So A21 is again cos 90 degree, 2 and 1 relation because height is fixed of the room as we see in earlier slide they are having angle 90 degree. So A21 is 0. Similarly, A22 means y2 dash with respect to y2. Both rotate with 30 degree. So cos 30 degree. And last A23. Now that is important. A23. Here not 1 is coming. So A23 means y2 dash with respect to y3. What this is y2 and y3 dash having already 30 degree rotation and y3 are same. So y1 and y2 having 90 degree, that 30 degree rotated means remaining angle is 90 minus 30, that is 60. So that is cos 60 or we can say sin 30. Cos 60 is nothing but sin 30. So we have A21 is 0, A22 is cos 30 and A23 is sin 30. Okay. So these are the direction cosine of y2 dash with respect to y1, y2, y3. Similarly, we take y31, y3 dash with respect to y1, y2, y3 and we get the following tabular value of Aij: 100, 0 cos 30 sin 30 and 0 minus sin 30 and cos 30. These are an important direction cosine set which we calculated and explain how we get this. Now by using transformation law, Aij dash is nothing but Aij and Aj. After expanding these, we get A1 dash is nothing but A11 A1 plus A12 A2 plus A13 A3. Now we have value of small A11 A12 A13 and capital A1 A2 A3 is already given to question. So after putting the value we get AI dash is equals to 1 and a2 dash is equal to under root 3 by 2 and a3 dash is nothing but minus half. So these are the component from ai without ai dash to ai dash components. We have one the value of components given to us is 110. After rotating 30 degree, we got 1 under root 3 by 2 and minus half in the next Cartesian coordinate system. So we can calculate easily from 1 prime axis to unprime axis or unprime axis to prime axis, vice versa also by this numerical way. And such type of question are asking in the examination, so we can solve easily. So for today we are stopping here. In the next lecture we are staying after that. Okay, thank you.